I'm just finishing the Google form, and I will put the link here.
In the chat, okay.
Yeah, in the chat, okay.
We can re-announce it for during the break, so we plan to have a break within 1 hour or so.
Okay, give me 5 minutes. It's very easy. It's just to make sure that we have everybody registered.
Okay, Rui, if you want to share your first slide just to check if everything is going on smoothly.
Okay. Hang on. Can you see me?
We are seeing the presentation viewer, not the...
Yeah, but you can see the presentation, correct?
Yes.
The title. Oh, my bad.
Okay, I'll give you the floor to you, Rui. So, and I'm going to mute myself. So anything you want to ask, please put on the chat. It will be easier to manage and not to forget the questions, okay? So, you could interrupt, but I think it will be easier for Rui if we put in the chat the questions, so you won't forget. And then in the end, we can address it more smoothly, the questions. So Rui, the floor is yours.
Thank you. I hope that everybody is with us already. So before I start, let me remind everyone for the latecomers that we are recording the session. So everyone, please be aware of that. I'm going to have a short presentation on the software that we have been using to support the project, to support the operation of the pendulums. Okay, and I'm going to explain to everyone what we have been doing, what we are offering to the project, etc. I will try to encompass as much as possible all the technical issues linked to setting up a pendulum today. And then on Thursday, we're going to have another session where we will probably be talking about different pieces, software pieces that are part of this ecosystem, namely some server-side pieces that not everybody has to implement. But today is mostly towards and oriented to the fact of having a pendulum online, how we can create a pendulum. And so let's get started. Feel free, please, during the presentation to pose any questions that you have on the chat, like Horacio said. If there is anything that is that you consider to be urgent, I will not be mad at you if you interrupt me. Okay. So please feel free to join me. Okay, so objectives of the project. I thought it was a good idea to start with this part, to have the general overview of how everything fits together. I expect everyone to know this, of course, but I will nonetheless make a small introduction of the way that we see the objectives of the project are. One of the main objectives is to deliver a technological system that allows us to remote control experiments, namely the pendulum experiment over the internet. Okay. The pendulum experiment is selected not only for its wide use in the classroom, where we can study not only physical aspects of the experiment, but also mathematical aspects of the experiment, like the treatment of experimental data. But in this case, we are distributing a network of pendulums through different latitudes in order to be able to measure the variation of gravity according to latitudes, and also eventually according to altitude or other factors. So this is the basic idea for the project. To get us started, I also would like to remind everyone what is a remote-controlled laboratory or remote experiment. In this case, for education purposes, we have created a set of remote experiments divided into remote laboratories. And usually this is the outline, the main outline of such experiments. So we have an experimental apparatus, usually have a driver connected directly to that experiment that controls the experiment and the different hardware pieces of the experiment. And then you have a remote server that allows users to come online and access that experiment. So this is the general concept of a remote controlled laboratory or remote controlled experiment. In this case, we're going to be focusing a little bit more on labs because one lab allows for different experiments. And what we're doing here is a huge lab with different pendulums distributed around the world. So in order to do that, we have built already in the past a software framework that we call the HECLab, Remote Experience Control. And this is a software framework that supports the execution of remote experiments. And it was developed as a generic software framework for connecting and managing remote experiments. Okay, so it allows already for a number of options linked directly with the execution and management of remote experimentation. For the World Pendulum Alliance, the main features are that we are offering, and supported on this HECLab framework, we are offering real-time observation and collection of experimental data. This is the main feature for the whole project to be used in the classroom. Let's not forget that. This is a mere overview from the technological point of view. The main objective of the World Pendulum Alliance project is to bring this experiment into the classroom and to explore it within the classroom and have students and teachers take advantage of it. So the idea is to support multiple pendulums in a versatile and robust way. We wanted also to include a browser-based interface so that everybody can access it a little bit more easily than the version that you have been getting to know in the past few months. We'll be getting into that later on. We want this also to be usable in the context of the classroom or for students' assignments. So this is the main feature that we shouldn't forget. Okay, so make it available for your students. You may visit also the main project website at wpa.tecnico.ulisboa.pt. All right. So, jumping into the user interface of the software that we're using to control the pendulums. This is how it looks in a simplistic kind of way. The user is able to select the parameters with which the experiment will be running, and then it is able to perform the experiment, to launch the experiment, while it views and collects the data in real time. So before, until today, we had a Java Web Start application, which was downloadable to the PC, which is still in use, actually. I think most of you have, or many of you have already used this interface. We wanted to change that to a browser-based interface. We have done so now. It is already available for testing. And despite the fact that it's not open yet to the public, I will be showing you that version here today. We are using for this a Java platform, a Java framework called WebSwing, which, if any of you are familiar with, enables to run exactly this Java Web Start application on the server side, and enables clients to connect via their own browser to this application. So that's what we have been doing for the last couple of months, and today we will show you the end result. Evidently, the main concept of managing multiple connections between clients and experiments has not changed. So that is still one of the most important features of the whole system. So are you with me so far? No questions? Okay. So moving on, we also have a piece called the Hack Web. This is the main page where the labs or the experiments are usually presented. Some of you may have already seen this access page to access the experiments. This will also be changing a little bit, but I will show you in a minute this new interface also. So RecWeb is basically just a small application that is associated with everything that we do in Rec. Okay, it provides an API for managing Rec. It provides a web page to access to different experiments, and the API also allows for interacting with the system's database, user control management, scheduling options, etc. I won't be getting into that today. Those are more advanced options. We may look at them further in the future. So these are the two main links that exist today for the Rec Web. I will be opening them in a while. Having reached this far, I would say let's have a try. Better than words and showing you pictures. I would now open the latest version of HikeWeb and also the latest version of the user interface to show you how it's working. Very quickly, we have now a test version which is deployed in Lisbon, which we will be opening to the other experiments. In the presentation, you may see still the name Valparaíso because that's the experiment that we used as a basis for the testing. It is already running over JDK 11, Java Development Kit, sorry. So it's on Java 11, which is one of the latest Java versions. So we've done that upgrade as well, but that was a while ago. And I'd like to remind everyone that the client is served over the WebSwing framework at IST servers. This is courtesy of webswing.org that allows us to use their framework for the project. Okay. So without further ado, I'm going to show you this is the access to an experiment. This is the testing experiment, which is deployed at Technical. Okay. So I'm using my browser, as you can see. I'm not using the usual Java Web Start launching plan. All right. That many of you, hopefully all of you, have seen this far. So I'm using my browser to access the same interface that we had before. So I'm going to write my username here. Okay. There's no need for password, and I'm entering only one lab. I'm going to go for English. Let's see how that works. So right now it's connecting to the experiment and also over WebSwing. Okay, so I'm entering the experiment. Like I told you, it has the name of Valparaíso, even though this is just a testing facility at IST. We have the video over there, which we can see from up top. So I can pretty much just do the same things I would do in the previous interface. It's the same interface. I can have a default configuration. I can have less samples if I want to. Then I have to send this with the OK button. And now, as the experiment is being configured, that may take a while. I also invite everyone to view the description of the pendulum. This can be edited by each partner if they want to. Okay. Now I have a small message down here. I don't know if everybody can see that, but I'm going to. Sorry. So I have a green message over here that at the bottom left, bottom right corner. Sorry. where I can use it to acquire control of the experiment. Okay, so now the experiment is configured. I have set my parameters to the experiment. Please watch the video as it moves. We can augment the video into a different window. Please let me know if everybody can see. If there's anyone with difficulties, just try it on the chat. Okay, now it's moving with the parameters that I've set. You will notice in the background that I'm already receiving the data in real time. So everything works just as before. The interface is basically the same. It's just over the browser. Okay. I also have a graph for the histogram. And I'm calculating the G value, the value of gravity, as I go along. So that's it. So it's pretty simple. Not much to it. It can be used simply in the classroom. Eventually, then you can open the different experiments as you do different data collections. They will be stored on this left side here. You will have access to all the data values that you may need to revisit. You can come to the results tab for your most current experiment ran. And over here, you can also see other users that are logged into the interface. I already have some colleagues over here, which is nice. Thank you for joining me. So that's it. I'd like to show you also the rec web page, which will be also available, which we will make available with the usual access to the laboratories. Here we still have a button that says download. This is going to be changed into a button that will allow you to simply connect to the experiment that you want. As discussed previously, we will be working on another model for this web page for you to access the experiments with a different design. We'll be letting you know when that is ready, and we'll be sharing that with every partner that for you to see and for you to also evaluate and comment. Okay. All right. So let me just I put on the chat these web links that you can also access them and try it out. Let's have a test run if you want. Sorry. And let us know if you have any trouble. Okay. All right. Continuing with the presentation. I'd like now to talk to you about a few more technical issues, deep diving into what we call the architecture of the software and how this will enable different people and different institutions to come up with their own experiments or set up their own pendulums, which will be the starting point I would advise for everybody. So let's take a look at the software architecture. The REC architecture, it's composed by three main modules: the hardware server, the multicast controller, and the client, the REC client. I don't probably if there are people here from other trainings, I've already explained this before. We're going to deep dive a little bit more into it today with the help of my colleague João Cortes, who was also in the meeting. He's been programming some of these things and he's been rearranging. He's the one who did all the support for the WebSwing platform. Him and our colleagues Pedro Matrola. So they are the two main developers and administrators for the solution. So in this solution, we have the hardware server, which basically serves all of the hardware of the experiments. It usually has a driver connected to it, and this driver will communicate directly with the experimental hardware. Okay. Then we can communicate over the internet with a piece called multicast controller, which will basically coordinate all activity within the system, namely users coordination and authentication management. So every single action that is taken within RecLab has to be authenticated as authentication linked to it. So even though we allow for anonymous users, every user as an authentication and authorization management. Then this will be connected to databases. The main database for HiCloud will store pretty much any of the data that is collected from the experiments, and we can eventually also retrieve this information and work it in other ways. So that is also an aspect that I can call out for anybody who eventually wants to do something with it. We are storing all the information from all the data from all the experiments that they're being run. And then we have a client. This client is what I've just shown you, is now being served on the servers. And you can access it with your browser through the link I've shared with you, and that we will be sharing also in the future, a link with all the experiments. This client basically is just a Java application that will generate a graphical user interface. And for each experiment, this graphic user interface will have a small plugin that will correspond to the customizer to the customizer of the experiment. So that itty bitty part that I've shown you, where you can set the experiment parameters. And also the results tab. This is another plugin. So this results can be in the form of tables, graphs, gauges that you want to program by yourself. You can go wild and you can do a lot of stuff there. Evidently today we're going to be covering the basics. I'm going to show you what we have for the pendulum experiment, so that you have a good assessment of what is a pendulum and how it functions. And then if you want to explore and have a little bit more fun and go creative, you can do that eventually. So throughout the throughout the rec architecture, we have separated these three parts: the hardware server, the multicast, and the client. We have separated them with what we call meta models for abstraction of the hardware and abstraction of all operations. So we have different meta models being implemented in all these communications between all these different parts of the system. A hardware description meta model that describes basically how the hardware is assembled and the different variables that are there that compose the hardware. Hardware behavioral model. So this is basically a state machine that I show here very simply on this side, that has different states from unknown, stop, configure, start, or resetted, and their transitions. This state machine is also explained in a few white papers belonging to the eLab and RecLab ecosystem that we can also make available for you to study if you're into that. Then we have a data transfer model. Basically, we create our own type of data for physical information where an experimental error is always associated. That is the biggest change, but also where we can work with frequencies and not only the number of data that is collected. We can also work with sampling frequencies for the data. And other binary formats if you want to work with them. So the data being conveyed from an experiment can be pretty much a black box of bits and bytes that you can create, where you can create your own idea or concept. This is advanced options, of course. For now, we will be sticking to the pendulum model. And then we have a user coordination model. That allows us to describe which users are connected to which experiments, which users have authorization or control privileges over an experiment, etc. Also with authentication and authorization, so every action requires authorization for the user. Of course, now that we allow guest users to do everything, but there are modes where we can implement privileges to super users or something like that, namely for scheduling of experiments. So this is already something that exists throughout the entire framework, okay? Just wanted to let you know. So very shortly, we also have these internet connections that I've shown here, or here, if you want. They're now over Corba. This can also be changed in the future, but for now they're still over Corba, and they basically enable us to create and to interoperate with different experiments or different user interfaces that may exist. If you want, you can create different user interfaces from scratch, or you can connect with existing experiments, even if you already have remote experiments that function in any other way or with any other system. You can create a driver that fits this system due to these meta models of abstraction of hardware. You can just create a driver that will function with this experiment just as well and connect to the multicast controller, and you don't have to worry about the user interface, about building a new user interface. You can just add that to the user interface. So these are just a few ideas for interoperability. I'm not going to get into it very much, just so that you have an idea of where we can reach. So any one of these intersections or areas, you can use the APIs or the communication protocols to build your own software from there. Finally, we have outside the scope of these pieces, we have a video streamer option. In which we have a webcam, usually just streaming a video file, and we have a video streaming server, usually over our TSP, and then we have a small video plugin within the graphical user interface that is just basically going to acquire the video streaming and place it atop the graphical user interface. Okay, so if I come back. Oh, sorry. So if I come back at this interaction, you can see here on the user interface, we have, this is the generic graphical user interface, and then we have small plugins for each experiment. We have the description, the controller, the results tab. So these are all plugins that you can create by yourself and you can also create the different graphs that you want. And then you have a small window here that is basically just capturing the video streamer from the webcam, from the webcam corresponding to this experiment. Okay. All right. So moving on, I don't know if you have any questions. Nice. So it's fairly simple conceptually. Evidently, if you start diving into it, there's a lot going on behind all this. So I'll just move on. How do we set up a pendulum? So this is all very, very neat, but how do we get our hands dirty, and how do we get into getting a pendulum online? Well, we have two different aspects that we need to concern ourselves with if we want to set up a pendulum. The first of which is the apparatus. So this is the part with the hardware that is being shipped and shared with all the partners in the project. The second part is that the one I'll be diving more into is the driver and the client. How do we create these software pieces so that we can connect to a pendulum? So to set up a pendulum, let's look at the hardware part. The main requirements is that you should have personnel, and please keep this in mind, because a partner who wants to have a pendulum online, you're going to need to have personnel with some background on Linux operating systems or Raspberry Pi operating systems. I'm being a little bit broader here. I'm calling it Linux, but Raspberry Pi should be enough. But please try to have in mind that these people operating the pendulums or setting up the pendulums, they need to have some knowledge on networks and administration of systems administration. Okay, so networks and setting up some services or simple batches, things like that. Okay, so this is important so that you can get the pendulum running properly. For the pendulum structure, I share a link here with you that where you can get more information. Is not the most updated information for the WPA project, but it has plentiful information on the hardware, how it's supposed to be assembled, how it's supposed to function, and namely how the DSP can function and connect to the Raspberry Pi. Okay. As for the Raspberry Pi and the webcam, these are essential elements of the hardware that you're going to be assembling. So the pendulum structure comes with not just the frame, the mass, and the wire to hold the mass. It comes with a glove mechanism to set the mass into motion, and then it has a photo gate to measure. The photo gate is not just photo gate; it has also a crystal system to measure the time with which the photo gate is interrupted. And these are signals that are sent directly to a DSP controller, and from there to the Raspberry Pi. And the Raspberry Pi is serving the hardware server. Okay, so I'm going back just very shortly. So this piece of software and the driver are within the Raspberry Pi. The experimental hardware has got the pendulum frame, the mass and wire glove mechanism, the photo gate, and a DSP. Okay, and this DSP has also a large set of instructions that you can eventually use for control. If you want to go deep enough into that level, you can see them in this first link as well. Okay, you can have some instructions in this first link as well to handle the DSP operations. As for the instructions to assemble the Raspberry Pi, to configure the Raspberry Pi and operate the Raspberry Pi, as well as for setting up the webcam, they are extensively outlined in this link, which I will show to you. So I will be sharing this presentation with everybody, and I can also share this link in the chat room as of now. Okay, so this is the link with the instructions for the precision pendulum software management. Okay, so here you have the contents for the Raspberry Pi, the software management, how to install the operating system, to configure the Ethernet, etc. And then you've got some more specific things on how to set up the hardware server and the video streaming server. Okay, so these two are quite important for the project per se. You're going to need to see how this is done, and we'll be, at least for the hardware server today, we will be going into that a little bit deeper so you can see how it's done. Then you also have some instructions on how to program or how to function with the DSP firmware. Okay, so there's a lot of useful information here, important information here, that anyone setting up a pendulum needs to take a closer look at, have a closer look with some careful attention, because there's a lot of information here on what you might need to know to set things up correctly. Okay. Now, primary pendulum partners, or the partners of the project, they have this shipped already with everything installed. So the Raspberry Pi was already assembled when you received it. The hardware server, we've also been doing that for you most of the time. So You don't have to worry much about this, but if the network starts to grow, you're going to need to know how to do these things by yourselves. So remember, have some key personnel with some knowledge on these kind of systems administration to help you out. Okay. Questions? Right. Am I still online?
Rui, sorry. I think Junio asked the question before in the chat. Don't think if you responded to it.
Oh yeah, there it is. Sorry. I thought this would have like a pop out to warn me, but I'm not seeing it. So Junio asks, what is needed for the checkbox where you inform if you're connecting from a public computer? I would say, Junio, keep an eye out on the second part of the presentation, because we will be going to talk about that a little bit more, and I'll get back to you on this after the presentation. Okay, thank you. So for now, I will be continuing with the presentation, and on how to set up a pendulum, we get to the software part. So here we're going to need to look at a few things like the driver, how to set up a driver, how to set up the client interface, and then how to build and deploy everything. So about the driver, about the driver and the client, they work a little bit hand in hand. I will be going into that. Into that in a short while. In the meantime, let me just remind you also of a few requirements. If you're going to be working on this, sorry, you will need someone with background on Linux operating systems and systems administration. That is very, very useful and important. Also, XML notation, a good knowledge, or this is up to you, the depth of knowledge on Java programming language, depending on how far you want to go. It could be helpful if you have the NetBeans IDE for developing, and also for building. You should have some knowledge about Maven and Ant. We will be using GitHub as a code repository and management system. And finally, we will be using Docker to serve everything. Okay, so these are the main technologies that we will be approaching. So it is nice if you have people with all of these, some experience in all of these and some background on all of these. If you don't, that's not necessarily a disadvantage, just depending on how far you want to go. Okay. I also would like to remind everyone that even though we might be talking about some more advanced items from here on out, that we will be available to help you in setting up your pendulums and clarifying any questions that you may have throughout the rest of the project, evidently. Okay, so please don't be afraid if this is too much for you. But keep in mind that having someone with this knowledge will facilitate everybody's work. Okay. So I'm having some questions here. Let me just I've got someone. Sorry, Alida is using if we can use a Linux emulator on a Windows as Cguin. Yes. Eventually we can to access the servers, but that will be also a little bit up to you, up to the servers that you have. Okay, let's dive into it. So to create the driver and the client, I'm going to be talking about these two in a very generic point of view, and then I'm going to show you how it's done. The driver is basically set up by two different files. These are XML files. These are descriptive files, and we call them hardware info and RS232 config file. Hardware info will basically be a file that will contain the parameters, the acquisition frequencies, or number of samples, and the data channels that that the experiment will provide, will hold. The parameters are basically what we see. Sorry, let me just find. Okay. The parameters are basically the input for the experiment. Okay, so these are the configuration parameters, the parameters that the user will be configuring in order to start the experiment. The data channels, what we call data channels, are basically the results tab, or the variables or the values that we will be getting from the experiment itself. These will be coming from the hardware itself. Okay. And this is usually done through an RS-232 port, which is a COM port on the computer. It can also be used via the USB port. It's the generic class can be the same for both. And this COM port usually just receives text, as many of you might know. And here also what we are configuring are the parameters that we are sending out or receiving in, and then some timeouts and hardware errors messages, okay? Okay. Sorry. So, so these are the two files that we will need to configure. This is how it links. These are the schematics for the classes as they map out in the software. And these, if you look at the schematics that are presented earlier, this is the experimental apparatus. This is the software apparatus. This communication is performed via our S232 COM port or USB. And these parameters are transferred, or they're acknowledged from between the driver and the apparatus through an ID of the experiment. This ID needs to be replicated in both these files, Arduino info and RS232 config. This will be basically the same ID that will be identifying the whole of the experiment. So if we take a very quick look at Arduino info, we have something of this sort, parameter name, then a selection list with a minimum value, a maximum value, and a step value. Sorry. Then we can also define frequency scales. These are acquisition frequencies that we are setting up for the experiment. We can also have a sampling scale, which is the minimum and maximum number of samples, and the step with which we can request a number of samples to be acquired. Okay. Then this is the file of our S232 configuration. So at the very top, we have the ID for the experiment. If you take a closer look, I'm not sure if this was, no, it wasn't. So at the top of these files, these XML files, you always have the ID for the experiment. And then here you can configure a bunch of frequencies. Heads up on this ports restrict variable, which is the port that you will be using to communicate with the experiment. That's usually the COM port that we are using, which is usually known as TTYS0. This can change, and you can change this, but be aware, you need to know what you're doing in order to change that. Thank you. Then we have a bunch of parameters. These are outputs that we are sending to the experiment, from the software to the experiment. And then we have the channels, which are inputs from the experiment towards the software. Okay. Then we have a series of timeouts that we can configure. Timeouts for the experiment. The hardware has died. The port has died, things like that. And then we can also define a bunch of error messages that are already defined for the pendulum, for instance. Here are just a few examples, but these are defined in more detail in the links that I've provided earlier. Okay. After that, let's talk a little bit about the client. I will be showing you these files live in a few minutes. I just want to give you a feel for how we can do this setup. So as for the client, we were going to need to configure the customizer, at least the customizer, and the data displays for an experiment. Okay, like I've shown you before. These are data displays, and the controller is the customizer. Is what we call the customizer. So these are going to be plugins that are going to be taken from what you have programmed and applied onto here. So for the customizer, you have to create one from scratch if you want to do a new experiment. As you will see with a pendulum experiment, we already have a customizer that fits a pendulum. So you can just copy paste this one. We're going to take a look also how we can do that later on. But if you want to create your own customizer from scratch, then we recommend that you use the NetBeans IDE for developing this class. This is a Java class, one, that you will need to build. And this simplifies enormously the work done, because you can just drag and drop all these elements in a visual fashion. You don't need to program the text boxes as in encoded text. You can just do it in a visual way with sliders and text boxes and setting up all these labels. You can do it in a visual way. It's fairly easy. So that's a recommendation there. As for data displays, charts, tables, and other dynamic displays, here is where you can go creative. Evidently, we already have a set that works for the pendulum, like I've shown you earlier. So we already have a data table. This is fairly common to any experiment that you want. You should always have a data table with the associated errors for each channel. And then you can build your own graphs, your own graphics. We have these two for the pendulum experiment. You can create others. You can also create here, if you want, other types of displays that you want, but those are at your discretion. So you're going to have to program your own Java class to show here what you wanted to show with the data coming in to the experiment. Okay. So right now, these are the two things that we're going to focus on. Like I said, these are Java interface classes, so you can use some Java interface classes to build graphics, to build tables. But if you want to go further than that and create your own displays, then you need to create your own Java class. Okay. Finally, we have a file, another XML file called recfaceconfig. This is another XML file. I know you can read it very well, probably what is here. I'm going to be showing you this with more detail in a minute or so. But you have also the ID for the experiment. And this is where you're going to place all the locations for the classes that you've created, for the images that you want to use in your experiment, and for all the displays and for the customizer class also. So this is the customizer class location, for instance. You're going to put here the path to that class, and you're going to put here the path to all the resources in your experiment. Namely, you're also going to have an URL for the video. Okay, so this URL for the video will also be centered here at the recfaceconfig. This XML file will basically have all the variables necessary to build your own interface. Okay, this interface for the experiment. Okay, so all elements should be presented here, including the URL for the video stream. Okay, so the customizer code. This is just for you to get an example of a few things that you eventually, even if you use NetBeans, you're going to need to have a few callouts to other Java classes that are in the system, namely the getAcquisitionConfig class. Okay, to set up the values of your parameters. Okay, So we're going to need to call these out, and so that's why this slide is here, so that the call out is made. Okay. All right. Finally, for the client, Rackface config will also make use of another resource bundle that we call Rec resource bundle, and in it, it's a file called messages.properties, and this file will hold all the labels and actual paths and locations for every single item in the experiment. So if you notice at trackface config, here we're just putting key values here, customizer.world pendulum, display.table.tip, icon table, table title, table location, etc., etc. And even the video URL is identified with a string called url.video. Excuse me. So here at this file, messages.properties, we're going to input and centralize all the final input values for the labels and for the locations of the items. Okay. This will include the description, for instance, the location of the tables, and other displays, the video URL, the actual URL for the video. So all of these things will be centralized in this file. Yes? Okay. So I'm going to get into this. So this is just a schematic so that you can see what goes in where. So you have Arduino info config file, our S232 configuration file, type config, Rackface config file. You have the displays and tables. So these three XML files need to have the same ID as the ID used between the driver and the hardware controller. So this ID has to be replicated and equal in all of these elements. Okay. In here, you're going to put the video file, the URL for the video streaming, and then you can create displays and tables, which you will identify with a location at this file here. All of these elements will be bundled together when the experiment is built, and they will be used to create this this driver here and the generic the graphic user interface. Okay. So this is just to give you a bit of a general overview of how this works. So at this point, I would suggest that we make a short recess. We can, or I can show you, but I don't know if Horacio wants to make the recess now, or if I should carry on. I have about another half hour of talking to do. Horacio, how do you want to proceed? All right, so just not to leave you hanging, I'm going to show you now exactly what are the steps as to proceed to create, to start creating these files. So, because I'm seeing a lot of questions here, so I'm just going to jump into that. And I think this will answer a few questions here. We have tried to summarize a few of the steps that you will need to do to get started. First of all, the project is available on GitHub, okay, with this link that I can also provide to you. Although you won't be able to access it unless we give you access. Sorry. Okay. You won't be able to access it just now, but we might give you access later on. It's not a problem. Okay. Here we go. So all the software project is available here. Please mind that the software is provided under an open source public license, the GNU public license version 2. Okay. So be aware of that. And in order to get started, I'm just going to show you now how to access the file, the project on GitHub. Okay. So this is the file. I'm working on this. We are working on this branch, JDK11 migration. We will prepare a branch so that you can access and test if you want to. We will provide a branch for you to download and access locally, okay? And you can do these things locally, and you can try them out locally and evidently test them on your own servers with your own experiments, with your own pendulums, okay? And of course, let us know if you need any assistance. So this is the project here. It's got a bunch of stuff already. We're going to want to go to experiments, and within experiments, please raise your hand if I'm going too fast, or if you're missing on anything. Inside the experiments, you've got a bunch of experiments that are already available on eLab, and then just because they're alphabetically ordered, at the end we have the world pendulum, and we have already a number of them available for you. Okay, so I'm going to access a specific folder, which we call WP template, World Pendulum Template, which is basically the folder that we are using to whenever we want to create a new world pendulum. Okay, we're just going to take this pendulum. Yes, I say again, sorry, there are people asking that they can't see the repository. This repository is private for now. Please send us your emails or username accesses for Git, and we will provide you access to the repository. Okay, just send us your username, and we'll provide access for you. So I'm going to access this folder. Apologies. Called WP template. So basically this has a structure of a world pendulum inside, which you can use to create a new pendulum if you want to, okay? I'm going to show you the files that I was talking about. In here, we have these different folders. I'm going to start with this etc, okay? Which is going to have those resources inside that I was telling you about. So here we have regfaceconfig XML and rs232 config XML. Okay, let's start with the rs232 config XML, so you can take a closer look. Can you see it? I'm going to try and increase. Can anybody see? I hope that's all right. Okay, so as you can see, you've got the ID right here. This is an ID, generic ID that we're using. So this is going to be, if you want to create your own pendulum, you should replace this. You can eventually do it right here by editing this file. I'm not going to actually edit, but you could go eLab, like WP template. Okay. Sorry, not eLab, of course. Just WP template. So you got the number of channels. These are, I remind you, the variables that we will be receiving from the experiment. Minimum frequency, these are the frequencies at which we are expecting to receive data. Okay. So please be reminded that these frequencies are the frequencies at which we are expecting to receive data through the RS-233 port. You've got the baud rates for the port. We got the stop beats, and then of course we have the ports restrictions. That you should be careful if you want to change this from a COM port to another. You should take particular closer attention to this one. Okay. And you may need to change it somewhere else also, all right? I'll get into that later. Then you've got the parameters. In this case, we're just going to have two parameters, which is going to be the displacement of the mass, the initial displacement of the mass, and the number of acquisitions that we're going to want for this experiment, okay? So that is what the software or the user is sending to the experiment, okay? For each of these values, you got an input. Sorry, you have for the input a max value, a minimum value, and an order, which is the step by which it can be increased. Okay, then you have the channels, which is what we are expecting to receive from the experiment, and what will be translated into a graph or a table. Okay, will be moved into a graph or a table. These are the formats for the lines that we are expecting to receive. So these are basically numbers. These are numbers that can take a decimal separator and up to four decimal places. So because we want the pendulum to be super accurate, so we're expecting eventually to have 4 decimal places, and we're not going to need them all if they show up. So we should have this format pretty and outlined. And we got a bunch of timeouts. These are usually you can work them out through experience, and then error codes. Okay. So this is basically the RS-232 configuration file. Okay. I'm not going to save these changes because I'm working on the template. Oh, right here. Sorry. And now I'm going to go back to where I was. So I'm at this directory now. Before I go to recface config, I'm going to show you a few other things first. Okay, and I'm going to come back to this one. So WP template. I'm going to enter this file, which is called source. In here we have Java source, and inside the server we have another file, well, a bunch of files with this path, and inside we've got the hardware info XML file. Okay, so basically the RS-232 configuration file and the hardware info configuration file are what will constitute the driver, or to build the driver. The two main, they hold the two main variables, the main variables for building the driver, and then the rest is for the client. So you've got here the same ID. Okay, remember this is the same ID as expected on the configuration port. Okay, so this is the same ID that is expected on the COM port. Then you have some variables. You can change this one. Please be advised that you can change. This is the name of the experiment that will show up in different parts of the interface. You can have another name here. The rest you don't need to worry so much. Then you've got the parameter list. This is the displacement again, and the number of points. This is the sampling interval. So these are the frequencies at which we are expecting the data acquisition to be made, to occur. And the sampling scale, which is the number of samples that can be requested. There's a maximum of 1,000. And then we have the channels. The channels, again, is what are expected, are the variables that are expected to be received from the hardware. Okay. Again, please note that the names here that might show up on labels. So on this file, the names here might show up on labels throughout the interface. So we are converging them and centralizing them on the messages.properties file through these key labels, through these keys. Okay. This also happens because in this case, the label for the variables and the units may vary. The name of the new units, not their physical meaning, The name of the units will eventually vary from language to language, so we should have this internationalized through the messages.properties file. So this would be channel 1, channel 2, channel 0, sorry, channel 1, channel 2, channel 3, and channel 4. And that's it. Okay, so I have a number of channels with physical values of different types. These are all floats, because that's what we're expecting. We're expecting a lot of decimal places. On the parameters, not so much, so we can have integers. So that's it. So this is fairly simple. I think it's pretty much straightforward. Not much to it. You just need to know how your experiment will work physics-wise. What is the physics behind the experiment? What are the parameters that it will receive? And what are you expecting to receive from the hardware? Remember, the hardware is being controlled by a DSpeak, all right? And this DSpeak already has a number of functions that will be translating the values, the acquired values, namely the period of the movement of the pendulum. This will be translated already directly into text into the software. Okay. I'm going to go back. Yeah. Any questions? All right. I'm just going to go back to WP template, to the original folder. I'm going to go back to. Oh, sorry, I forgot something. Yeah. To go to source, Java, and here we also have, besides the server, which is where Arduino is at, we also have a folder named client. This is for the user interface. So let's go into that. We also have a number of folders to pathway all the way to World Pendulum, and here we're going to have the Java applications, Java classes. Here we go. So we have a pendulum customizer panel, which I will be showing you in a minute. And then we have the different displays. One graphic display, display for the period. We've got the histogram, which we were seeing back there. We can have a sensor, which isn't exactly working, but you can build your own. You have a table, which is the pretty much usual table that comes with every experiment. And you have also this default table that allows you to build the table. If you go into the table function, for instance, you'll see it's very simple. So you just import the default experiment data table. And here, all you have to do is just set the class, and it'll just do the default table, okay, with all the parameters. So you already have a number of classes that facilitate this work. Let me see, table model. Okay, same thing. All you have to do is import, and you just have you can just have the default table just showing up. If you go to the graph display, I think, check this out. Please remember to put mute everyone on your mics. Thank you. Here to define a graph, all we're doing is we're using a usual graph display that is already set up within the framework, and we're just setting the x and the y axis. The x-axis will have channel 0 as its base, and the y-axis will have channel 3. All right, so this is the number of the sample and the acceleration of gravity. So that's it. That's what we're already acquiring. Okay. Sorry, this is Portuguese. The comments we can eventually change that to English. But basically, if we go to this is what you have. You have the number of samples, which is channel 0, and channel number 3. Sorry, this is which should be the acceleration of gravity.
Wait, that is wrong. Is the velocity?
Yeah.
In Portuguese is correct, but in English this is the remaining thing that lasts
Yeah.
forever.
Okay. Yeah. This is a small bug on the label. Sorry, guys. This is the
Is in the dictionary. The translation is not correct.
Yeah. Okay. Yeah. So we need to change that label. Okay. Sorry, guys. But okay, I think everybody gets the point here. Oops. Okay. So this is fairly simple of assembling. If you are familiar with Java, it's very, very straightforward. You don't need to have great knowledge over the programming language, unless, of course, you want to build your own displays. And there, we would advise you to explore this a little bit differently and to have a bit more of a tryout. As for the customizer, I'm just going to take a brief look into it, because this is it's usually a bigger class, so you can see it's got a lot of components in here, layout components, and this is why I was telling you that in order to build this class, if you're going to build it from scratch, you can take advantage of the NetBeans IDE, because this will allow you to create all these elements in a straightforward fashion of drag and drop. Okay, but every one of these elements is a text field, displacement unit, attributes, etc. You can name them. Yep. The ticks, the minimum ticks, etc. So this is all formatting. This is a class that is just formatting all this interface right here. Okay. The squares, the buttons, and sliders, and etc. All of this is just being programmed via this class here. And then at the bottom, I think it's at the bottom. Just have a search here. My bad. Okay, no, it's at the beginning. You're setting the values for the loop customizer, and just search here. Here we go. So at the end here, you have a number of configurations that allow you to pass default configuration. Okay. So these you're going to have to pay closer attention to, and yes, you have a number of options to pass the values onto the data acquisition config properties. Okay. Just okay. So this would be where you configure the variables. Okay. So you need to do this by your own. What we would advise you is that you copy or study some of this code so that you know where to go. You need to call rec resource bundle in order to provide the labels, and then you need to also call some action listeners, etc. Okay. So this one may be a little bit trickier for you to get, so I advise you to study this one of these classes in advance so that you know or you understand what it's doing. Okay. So for this, eventually you need to have a few more bases on Java programming skills, okay, so that you can do this type of work. Okay, so that's a little bit of what we have at this option, and then inside, sorry, just inside this class here at the client, you also have the resources where you're going to find two important parts, which is the messages.properties file. And this messages.properties is what is translating those key labels that we've set out earlier to their actual locations. And this is the icon for the experiment. This is the tip. This is a short description that's going to show in some of the labels. This is the customizer location. Okay. So this is the location for the customizer class. Sorry for the formatting, but this is the title for file or any other that you can have. This is the description. The description, please note that it accepts HTML formatting. Okay. So we're just putting one block of HTML right here, which will provide you this description right here. Okay. So this is done in HTML. Then we're separating this with displays, location, title, or tip actually, and title. And eventually somewhere here, where we'd have to change that label that we saw that was wrong. Okay. We can do that shortly. This is for one graph. This is for the other graph. You can have other things right here, and then you have the URL for the video. This is to be replaced automatically. That's why it's like that. All right. And then you have labels. This is displacement in Portuguese with an error. My goodness, sorry. The different channels and their names. And then the units also. Okay. You may have to use different formatting for to get some symbols in there, some ASCII symbols. Okay. You can do that. And that's about it. So it's pretty simple. And if you take a closer look also, you can have a file in English. Okay? You can have the same file in English, and depending on the language which is selected by the user, is going to present either language. Okay? Please note that here I do not have the URL for the video. So the URL for the video can be set only on one of these files. If it is not found on the file for English, it will search on the file for Portuguese or in any other file that will contain that variable. Okay, so you don't need to replicate it in different files. You can, but you don't have to. So you can more easily just manage these language files. Okay. And that's about it. Finally, so this is a resources folder, and this is the client folder. This is what exists within the client folder. If you go back to the origin folder, WP template, within the etc folder, you also have the recface config XML. And here is where you're going to summarize all of these locations, so to build the client. So here, you're also going to need to have the ID for the pendulum, okay? And then everything else, the icon location, it's set in the messages.properties file. The display string, you can also have a string for display there. And then you've got displays. This is the table, this is the graph histogram, this is the graph for the period, this is the graph for the G. And each one of these lines will have a number of variables that you can use. Okay, this is the title. This is the location of the display class, the Java class that will um, create this histogram. Okay, so each one of these is display. Each one of these lines. You got the location bundle, which is the messages. Okay, which where we were at right now. So this is the pathway for that file messages. We've got the video location also with a tip that is going to be, sorry, not with zip, with the location as a key format that will be under messages. You've got a number of variables that you can work with. And that's about it. So just this will outline how your client will be built. Okay, you can have different displays here also, and other web resources. Okay. All right. That pretty much concludes what I would call the first part of the presentation. I would call then for having a recess now. I don't know if I expect, sorry, João Cortes, my colleague, to give you access to everyone who's presenting their users, their GitHub users, to have access to this, so you can visit it. And in the second part, which I hope will be a bit shorter, we are going just to review these steps and how we can actually create a new pendulum and deploy a new pendulum. Okay. So after this longer introduction, I expect the second part to be a bit quicker and more hands-on so that you can see how it's done. So right now, I would call for a short recess, and we meet back here. Horacio, in how long?
Yeah, I think, I don't know, we have colleagues in Brazil that probably needs at least a quarter of an hour to have a sandwich because it's lunchtime there.
Yeah.
So I propose, because it's almost 3:30, that we come around a 3:45, something like that. So
Okay.
we will, if you can, you suspend the recording, and I don't know if Anna is there, but I will ask her to suspend the recording, and we will back in a 3:45. Is everybody okay? If not, just chat something. Okay, Rui, let's do it.
Horacio, just
Yes?
remind the people that haven't registered, please do it while we are in the break, because we have half of the people in the participating here registered. So I ask the other half, please go to the Google form. I will put it once more here in the chat.
Okay, Anna.
All right, thank you.
Okay, take this opportunity, guys, to fill up the registration form. It's very important for us to have a feedback to give to Europe about the participation in these events. We have like, the top was 51 or 52 persons, and now we are 46. So it's very good to have you here, okay? So see you in a while.
Thank you. See you in a while.
Rui.
Sim?
Estás aí? Ok. O que é que achas de eu experimentar aí o partilho do ecrã? Pelo menos para ver se está tudo a funcionar bem.
Sim, sim. Go for it. In that case, I'm gonna pause mine. Try and do yours.
Ok. Ok.
Subscribe.
Consegues ver? Consegues ver o meu ecrã?
Conseguimos. Tá, e se a fonte é muito pequenina, ninguém consegue ler com esse tamanho de fonte.
Assim?
Assim,
Fica melhor?
assim já está melhor. Sim, já está
Ok.
melhor.
Ok. Isto fica. Ok.
Tu tens uma janela, deve ser o teu vídeo aí em cima que te corta parte do ecrã.
Ok. Aonde?
Aí na parte direita do teu ecrã tens uma janela preta, que
ok.
para nós fica preta, porque tu deves ter...
Esta.
ok, já está bom.
É o chat.
Isso.
Era o chat do
Era o chat, sim.
Zoom. Sim.
Calculei.
Ok. Só para ver se isto... Conseguem ver todas as janelas, né? Quando estou aqui no...
Sim, mas quando tu mudas fica com uma fonte muito pequena.
Ok. Este já é do IDE. Isto é que mudou. Ok. Se calhar abre aqui mais... uns quantos. Ok. Eu já dei aqui os acessos aos users.
Rui, este Git que estás a usar não é o do Elap, pois não?
Não, este é o nosso.
Ok. Isso depois tem que se fazer passar para o outro, não é?
Não estávamos a pensar nisso. Estamos a pensar em deixar o nosso.
E tu fazes a gestão dos utilizadores? É que se está privado tem que haver alguém a gerir os utilizadores, é só isso.
Yeah.
Ou então abres para público, é isso?
Sim, no futuro vamos abrir para público, já não haverá esse problema.
Pronto. Ok.
Ok, então convém fazer as coisas ao contrário, é pôr as coisas que estamos a fazer no Elab nesse Git. Estás a ver? Depois, não vai haver dois Gits eternamente.
O do Elab é o quê? A nível das experiências?
O Elab tem algumas experiências, muito poucas, mas tem os conteúdos, fundamentalmente os códigos da SPIC ou Stamp e tem os conteúdos pedagógicos que, em princípio, o vosso Git antigamente tinha alguns, pelo menos a nível de imagens e coisas assim do género, mas que nunca teve muito preenchido. Portanto, a Mariana está a começar a fazer isso no nosso. Também se pode fazer no nosso e depois juntar os dois. Não sei bem como é que isso se pode fazer, mas é uma questão de se ver.
O que eu diria era nós, quando este outro estiver aberto, vocês verem o que é que vale a pena migrar para este e não migrar. Se calhar era mais.
Não, eu ou migro tudo ou não migro tudo, não é? Este como é que se chama? É a questão também do nome, não é? O nosso tem um nome um bocado foleiro, que acho que é Lab Técnico, assim uma coisa, já não me lembro bem.
Mas, não sei até quanto é que vocês não podem ter o vosso para outras coisas, não é? Mas é uma questão de...
Não faz muito sentido haver dois para o Lab, a partir do momento em que o teu esteja público.
Sim. Eu tenho a de buscar.
O nosso chama-se Lab Técnico Lisboa PT, mas tu tens isto, não tens, ó Rui?
Sim, nós temos, sim, mas
Ok.
nós abrimos já. Estamos a trabalhar no nosso.
Ok.
Para nós é que faz mais sentido. Mas,
Olha, só uma coisa. Cabo Verde já está on. Expliquem-me lá o que é que querem que eu reverta, que vocês tenham feito, porque uma trola saiu entretanto e eu fiquei sem perceber. Pelo que eu percebi, vocês alteraram o broadcast.
Sim, do
Pronto,
ETH0.
e já está outra vez ok.
Ok.
Agora,
não
o que...
alteramos mais nada, não alteramos mais nada. Em princípio, agora é tentar perceber se a comunicação inversa está a ser feita. Era isso que eu ia fazer a seguir. Tentar perceber se a comunicação do multicast para o hardware server está a ser feita, está a ser estabelecida. Mas isso depois da formação, eu dou uma olhada.
Está bem, ok. É só para dizer que já está então no ar.
Está bem, obrigado. Já agora confirmo.
Já confirmei, já fiz login.
É? Ok. 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 Correto.
É que eu não percebo o que é que aconteceu lá, porque não se alterou nada. Cabo Verde já esteve a funcionar, desde que se meteu lá usou-se, é que aquilo deixou de trabalhar como deve ser.
Pois, é que eu por acaso havia aqui uma coisa que este ficou comentado, esta parte do 127.0.011, não sei se houve uma razão específica para isso, pois a apontar diretamente, porque eu estou a ver nos outros, ele está a apontar para o 127.0.011, no Valparaíso e no... Qual é que é o outro? No Marselha, está tudo a apontar para 127.0.
O 127.1 é o default da própria máquina, não é?
Sim. E este está a apontar para o IP da VPN. Não sei se existiu alguma razão específica, mas é a única diferença que eu vejo a nível dos hosts para os outros. Para os outros nós temos. Por isso é que eu queria confirmar se seria outra coisa.
Mas tu meteste para o 127 e...
Não cheguei a mudar. Não cheguei a mudar.
Então porquê é que aquilo deixou de estar acessível remotamente?
Remotamente foi a questão do
broadcast.
Do broadcast, sim. Bastou mudar isso que ele rebentou logo com... Mudou-se isto para a mesma network, para o mesmo octeto desta rede e ele deixou logo funcionar. Foi logo a seguir a isso.
Olha, a gente vai lá ter uma pessoa, mas só mais uns minutos. Portanto, se quiseres ter alguma experiência rápida que possa pôr em risco, digamos assim...
Não. Eu não estava a fazer nada em Cabo Verde. Em Cabo Verde era só para experimentar a ver se conseguimos pôr aquilo a funcionar. Porque a única que mexemos e já não mexi há algum tempo, só ontem é que levantei foi o Valparaíso, foi a última que mexemos, mas ontem levantei o serviço, aquilo estava em baixo, aquilo ainda não temos configurado lá o supervisor naquela máquina, mas o ideal seria ter uma coisa do género, para ver se ele se fosse abaixo, levantar logo automaticamente.
Pá, mas isso é que não convém estar a fazer invenções, convém fazer isso primeiro no técnico.
Sim. Não, eu não ia fazer já. Eu ia primeiro experimentar a ver se...
experimenta no técnico. E a gente assim consegue lá ir fazer reset.
Sim. Eu nessas não...
Por exemplo, Valparaíso e não sei o quê, são sítios que eles às vezes nem vão à universidade porque aquilo está em lockdown e não podem ir e é preciso autorização, é uma chatice.
Sim. Eu deixei de mexer nessas máquinas desde que vocês disseram para fazer as experiências no técnico. Isso cortei logo a ligação a essas máquinas. Não,
é que eu não percebo porque isto foi tudo abaixo e não sei o que aconteceu. Por exemplo, hoje, quando eu mandei aquele mail, não estava nenhum pêndulo online.
Ok.
Não sei o que aconteceu.
Há de haver aí alguma coisa.
Ok, mas a gente depois tem que voltar a falar depois desta formação de quinta-feira. Para operacionalizar depois esta compatibilidade entre o REC antigo e este REC.
Ok.
Porque a gente ou muda tudo para o novo REC ou não, porque senão isto vai dar uma confusão.
Sim,
ainda estás aí, Rui?
Estou aqui. Eu daria a gente falar disso a seguir, então.
Está bem, então. Não, só para saber, porque faltam 5 minutos. Não, estou a olhar para o relógio. Não era para discutir isto, era para olhar para o relógio. É como eu agora não estou a ver o vídeo, estou a ver aqui o que o Corte está a fazer.
Partilha. Sim. Estava só aqui a ver.
Sim, nós sabemos que estão todos a ouvir, mas não estamos a dizer nada de mais. Estamos a preparar a apresentação para 3:15.
Eu sei, mas era só pelo sim, pelo não.
Eu percebi. Rui, eu só sugiro é que tu pares a partilha se for o Cortes agora a trabalhar, senão
Eu vou tirar o meu share, depois eu vou
Não
apresentar.
está já parada?
Não, a tua não.
Ah, então,
Então,
mas deixa-me. Mas, ó Cortes, deixa-me só aqui fazer uma correção.
Sim.
Um complemento a uma coisa que eu me esqueci de dizer.
Sim, vou desligar, era só para experimentar também.
Não, já desligaste, que é diferente.
Já, pois. Já desliguei, sim. Era só para experimentar para ver se vocês também conseguiam ver bem.
Pá, não estou a perceber o que isto faz ao chat.
Quando tu fazes a partilha, o chat automaticamente esconde. Tem que se abrir uma tab ao lado.
Yeah.
Rui, tens aí uma opção que no chat de lado que consegues fazer merge with meeting window. Não sei se tens isso ativo ou não.
Merge o quê?
With meeting window. No chat. No chat tens uns 3 pontinhos ao pé de onde escreves. E tens lá merge with meeting window, que é para, se calhar isso estava popped out. E assim em princípio consegues ver o que é que estão a escrever. E também podes fazer isso com os participantes. Pode ser que alguém tenha a mão levantada ou alguma coisa. E assim vês logo tudo.
Muito bem. Salvar.
E assim em princípio aparece-te.
Não tenho que adorar isso.
Não estás a ver? Ou...
Não.
Consegues partilhar o ecrã? Se calhar consigo te mostrar.
Tenho isto. Consegues ver no chat?
Sim, o chat não está a aparecer por acaso.
Pois. Que faz parte.
Mas ele está popped out.
Tá.
Então onde tu escreves, no sítio onde tu escreves, onde tens tu everyone, do lado direito tens uma coisinha com 3 pontinhos.
Pois, eu não tenho essa opção.
Não tens?
Não.
Espera aí, eu vou-te mandar um print para o...
Mas deve ser porque eu estou a apresentar, acho eu.
Será?
Acho que é porque eu estou a apresentar, o gajo não me deixa fazer isso.
Então, espera aí, eu vou-te mandar para o chat.
Ok.
Mandar para o chat para tu veres. Tens ali aqueles 3 pontinhos, as reticências ali, não? Vê lá.
Pois é isso, mas não tenho essas opções lá.
Não aparece? Pois, então deve ser por estares a apresentar. É.
Estava a gerar a dizer que não conseguia entrar, mas já foi resolvido, certo?
vou-me ausentar um bocado. Ok?
Vamos começar agora ou corto?
É 5 minutos. Tenho que ir.
Okay, guys, we are going to have more 5 minutes break, okay? So we are going to have a practical class now, basically, let's call it practical class, with a live example. But we need more for 4 minutes, okay? So we'll come back 10 to the 4.
Sorry, I'm back.
Who you are going to resume now?
Yes.
Please. Okay. The chair is yours.
I will start recording again.
Please, and Rui as well.
Okay. Done.
Hi, everyone. Okay. I trust everyone is back. So, small note on one thing previously the break that I should call your attention to. Sorry, here in Java client world pendulum, I showed you the customizer panel.java. So I wasn't finding it, but the fact is that it is here. You've got, sorry. So at the end you have this a set of instructions for displacement, number of samples. So this last part here is the part that links to the rest of the software framework via this Java class get acquisition config. Okay, and this get acquisition config basically is created according to the hardware info config file. Okay, so it's going to have all the variables and channels that you define according to what you define in that XML. And then it's going to have a number of methods that allows you to set the total samples, to set the parameters, set the channels if you want to, etc. Okay, so this at the end of the customizer panel.java class, you're going to have this bit of software of code that you should pay closer attention to in this particular Java class. That if you want to change anything within this class for parameters and channels, you should look at it. Okay, I just missed that out previously. So having said that, and going back to the presentation, we were thinking about for the second part, which I hope will be going a little bit faster, and will also probably answer a lot of your questions that you've been probably posing, like what are you actually going to have to do? What are you actually going to have to touch? So having this broad introduction, or this broad, all these concepts that I've already presented, and where the code is and how you can access and work with it. Let's narrow things down to what you need to create a new pendulum and to have a new pendulum running. So we're going to do this as straightforward as possible. And then on Thursday, we're going to have a second session where we can go back at it and go a little bit deeper if you want to. But right now, we're going to keep things simple. And we have set out this as a three-step process, not a three-step, but it has more steps, but a three-part process if you want. Part number one is to create the project and commit it. Part two is to build it using Maven and Ant. And part three is deploy. Okay? So these are pretty much straightforward things that you can do to create a new pendulum. Let's start with the beginning, with the creation of a pendulum. And for that, I will pass on the word and the screen to my colleague João Cortes, who has been working on this, and he can show you how we can create a pendulum from scratch. Okay, and then João, you will show that part, and then if you want to, you can pass it on to me, so I can review a little bit of these steps that we just did with the XML files and the classes and the files that we need to touch. Okay. So João, if you want to, I'm going to stop sharing, and you get the con. Yeah.
Okay. Thank you. Good afternoon, everyone. So I'm going to share my screen. Okay. So now I have the project here. I'm using Visual Studio Code. For the project is the same as the repository that you were seeing. I'm working on JDK 11 migration branch. So now I will create a new experiment to be able to be a little more easier to create the experiment from scratch. We have created this script, this shell script that we can pass arguments so it can create a new experiment. You could also check another one and try to mimic it, but this way it will be easier to start up a new project. So now I'm going to position in this script. You have instructions. If you do not pass arguments, it explains what you need to pass. You need to pass the experiment name, the experiment ID, and you have examples that can be shown. The location where you will be, maybe Portugal or other location, and the video location that is optional. From this, for the pendulums, you will need the video, but you can also omit this section. So we can try to create a new pendulum for the training session. The experiment will be named WP training, and the experiment ID, we can also create a name, pendulum training. The location.
Cortes, you
Yes.
are not showing your screen.
No?
No.
Okay. Okay. Sorry. It says here that I'm showing. Strange.
Yes, I see at least the screen of Corta. I think it's what you intend to show. It's
Okay. Okay,
A
the
window
terminal.
is a terminal window, yes.
Oh, okay. Maybe.
You are typing now Lab World Pendulum Training Lisbon.
Okay. Okay. So maybe Pedro, you are focusing the other screen.
Yes, because I think Rinette still has the shared screen, I suppose.
Yeah, I'm not finding a way to shut that down completely.
I'm going to shut down for you.
Thank you.
Okay, it's better. Right, I can see the
Okay.
the court screen.
I was Googling how to shut it down. Okay, thank you.
Okay. So now I'm going to check the video where all that I have set to our server. But now I'm going to name it another. This is the streaming server that we are setting for the videos to be streamed. So now I'm going to publish I'm going to set the name to publish the stream to the streaming server. So now I'm going to say it is WP training, and now when we run it, it says that directly it works. And now I will have the WP training project created. If you can see, I have now the structure, and it's ready for us to start doing our changes. But this time maybe I'll pass to Rui. So I'm going to commit these changes, and now maybe you can explain some customization that can be shown, right?
Okay, thank you.
Okay, I'm going to commit it.
Um,
Though.
so, can you see my screen now?
I'm going to stop sharing.
Thank you.
Okay.
Hi. So back to these steps that we were doing. So what João Cortes just showed you is this first very simple step that we have enabled for all of you. We created a script to create a new pendulum experiment. So he has just created. I can't see it yet in my repository because he's still updating it. We just created a new pendulum called WP training. And that pendulum will have the exact same structure, as I was showing you before. All that folder structure and project structure. Okay.
It's already there. If you want to check it.
Cool. Nice. So if I go, sorry about.
WP training.
Here we go. WP training. So it's a new one. And right here, I'm going to have the same structure as I had before. I can go to etc. And the script already does a few things for us. Like if I go to the same files, XML files, I already have the ID that is set, that João has set. Okay. Everything else will remain the same because it's basically just a copy of the existing pendulums. So in this file, everything is the same. I don't need to change anything. In recfis config, the same thing. I'm going to have here, the ID has changed, as you can see. All right. All these names have been changed also. All the key names. WP training. Okay, so everything has now been set so that I already have the structure for a new pendulum. And this new pendulum is called WP training. Okay. So let me just also remind you of the client. Let's take a look at the client side. Java client. WP training, and We already have the customizer, WP training. So everything is already set. Everything is the same. The customizer will be the same. All these classes are the same. They have just been copied and changed accordingly to the name that we wanted to have. Same thing with messages.properties, probably. So everything is already set. The same thing with the video file. So the only thing that we're changing in the video URL is the name, is this last name, or this last caption for the URL. Okay. If you have another URL that you're setting up with your own webcam, etc., then you should come here and replace it accordingly. Okay. But if you do everything standard, as is provided by the project, then not much more work needs to be done here, okay? So these files that I've shown you before are pretty much the files that you're going to need. You may want to revisit anything, make sure that everything is in place. Now, there are a few other things that we need to take a closer look at. So all these will be created and prepared in a standard fashion via this script, okay? So that's fairly simple. After that, what are the next steps? We're going to have to eventually build it, build this project. So for that, we will need to be aware of a few more things that pertain to your system, to the system that you have, namely, where are your servers going to be? If you're using the same Raspberry Pi as we are providing for the Pendulum, or if you are using another server, then you're going to need to review a few more items, namely the build properties files. Okay, this is the preparation for the next step. So until now, if you're doing the standard version, you don't need to worry about these anymore. They have been created, and they're ready to go. Okay. So if you want to customize them in any way, if you want to take a closer look at them, you may. Then the next step is to start preparing the build. And for that, before you go into the build, you need to search some build properties. And I'm just going to cover the most basic ones. Sorry. Which is, if you go to, oh dear, sorry. We have prepared, sorry, in the project itself, in the root of the project itself, we have a file called build.properties, okay? So you should make sure that if you're doing this locally, if you're building this project for your local environments, then you should have a look at this file, okay, before you run the build. And here, there are a number of items and variables that you need to be aware of that pertain to the network in which the system will be functioning. Namely, if you recall about the architecture, we have the multicast connecting with the hardware server, and in this case, you're going to need to have the host name for the multicast. Okay. In here, we just call it LAB multicast because we'll be translating this at Docker level further on. But in here, you need to have the URL for your multicast. So if you're building this locally, your hardware server, and let me go back to the presentation over here. Sorry, just a second. Okay, so your hardware server will need to know where multicast is. Okay, and this file, this properties file, is where you define that. Okay, so you can have a URL here. You can have a URL endpoint here that your server, where you will deploy the hardware server, will recognize as the URL that will reach the multicast controller. Okay, so this is a pretty important part. If you're trying to build it locally and experiment it locally, you should be aware of this. Okay. João Cortes, please advise me if there's anything else that I need to call out here, especially.
Yes. So in the future, maybe this properties file will be used to join every pendulum. So you can also create. It is going to be explained in the build process later, but just for you to know, if you need to test and not work with this file, you can create another build properties file. Just need to add an underscore to the file, and it guides the build process. But I will show you in the next session. The only thing that is going to be changed also in this file, if you can go back up there, Rui, up, the pendulum experiment list. No. Okay, the build property. Yeah. So the pendulum experiment list. In this case, when we need to configure the WP training, we would change this to WP training instead, and we can separate it with commas and say another experiments. If you want to if we have 3 pendulums, for instance, you can create WP training 1, comma WP training 2, comma WP training 4, and the process guides through there. The same to the lab list. If you have more labs, you can configure with the commas, but it will be shown later. So just
we can look at that from a practical point of view.
Yes.
For now, the only thing you need to know is that if you're testing and building this locally, then you're going to have to pay attention to all the variables that are here. But this is pretty self-explanatory once you get the hang of it. You've got the experiment list and the pendulum list and the lab list, which is basically this. Okay, will be translated into this. So this is the laboratory, and you can have different labs, as in the current system, where you have different labs. One of them is a world pendulum, and here you have different experiments. This is the one that we're setting up already with the new system, but basically it will work the same way. Okay.
Yes, and some just another thing. The piece components, RecWeb and the hardware server communicates with the multicast, saying just a sort of tagging and saying that they exist, and then multicast establish a connection with a random port with that components. So it is essential to be careful with the setup of the ports. If you have firewalls and the other components in front of these components, you have to be very careful, because there is random port attribution. So just another note.
He was talking about this connection here.
Yes, the Corba communication, as you referred before.
That's important.
It has to be reduced to a class of addresses, now, like we have present.
Yes.
It is not so random that can be any. It should be in a class, let's say.
A range, yes.
Or in a range, predefined range. Okay.
Yes.
But I think you need to clarify. Sorry to interrupt, but at some point this is not being very clear, and we need to clarify if both servers are serving the same experiences. So I think it should be clear. It should be more clear for everybody that both RecWeb and the web swing are running in parallel. So that experiment, in your case, from Valparaíso, is common to the both laboratories.
Sorry, come again?
So that my question, if you want to interpret like a question, is that Valparaíso will be available both on the present RecWeb system and in your future architecture with WebSwing. So the experiment is the same, the RecWeb server is the same, but you can use both clients, the application client and the HTML interface.
Yes. So you can use them both, but the idea is to migrate to this new interface. Yeah.
Yeah, that's clear. But just to be to clarify to the people that in this case we could use as well the GNLP because you can download it from the page if you click on it.
Yes.
Okay, from RecWeb, yes.
Okay.
In this moment, yes, but we are changing the web page for only have a link to the WebSwing application.
Yeah.
Correct, Pedro. But what I'm saying is that if you run the old lab, you are going to have access as well through the application, no?
Yes.
Yes. So you can
At
have
this moment.
Yeah. Right now, you can access the same experiment via these both ways eventually. Not exactly for Valparaíso, but yeah, we can set it up that way if necessary. Okay. But okay, just calling your attention so that there is this file here, this build properties file. That if you're testing this locally, you're going to need to come here and review these variables with some attention, namely the ones we called out. Okay. So that's it. Evidently, this build properties is already prepared for when the system is built. It will reach and connect this existing system. Okay. So if you want to put a new experiment on this list, a new pendulum on this list, you don't need to change anything right now. Okay. If you stick to the standards, you don't need to change anything. All right. That's an important message right there. Okay. So going back to where we were, there's also another build properties file, and this one pertains to the experiment itself that I'd like to show you also. Wait, that was one step too many. Sorry. Experiments. And let me do training. Okay. Now here on ETC, there is another file called build.xml. Okay. So I'm going to advise you to also take a look at it. Namely, it sets how the distribution will be handled. So this will create zip files for the build. After the build, it's going to output the zip files that you can then deploy. If you want to change that eventually, you're going to need to look at this file here. Okay. So that's basically it. Again, if you're using the standard distribution, you don't need to concern yourself with this. Okay. This is just on case you want to do a few more advanced things. Okay. After having checked these files as well as these, you can commit all these via Git. Okay. So we'll leave here the main commands for performing a commit. And basically, we're going to have, sorry. Oi, oi, oi. I'm lost. What the fuck was it? Yeah, that was it. Sorry. Basically, after having done that, you're going to have a new pendulum code ready to go, and then I would pass also the word to João Cortes, where he'll show you how to build the project. The idea is now to perform the build, and with the build, we're going to create a package for the hardware server, and we're going to create the Docker images for the client, the rec web, the multicast, and the database. Okay, so again, let me just take you back to this original schema. We're going to create one package for this, which is going to be a zip package, which you will then be able to deploy according to the instructions that we have already provided. Okay. The instructions are on this page. Then we're going to create Dockers, which will hold and contain the multicast controller, the client, and the database. Okay, as well as the rec web page. So this page right here. Okay, so these are all services that will be under Docker, and that on Thursday we can take a closer look at what this means and how you can work with these if you want to. And these are pieces that right now only exist at IST, at the Technical in Lisbon, but that you will be able to replicate on your own servers, on the servers that you may acquire also in the scope of the project, and that you can install at your own place. Namely, you can have a multicast controller serving different experiments, serving various pendulums, and you can hold a client if you need to, as well as a video streaming application. So those three items we will cover on Thursday, how you can install and work with those. Keeping in mind that the build system is the same that we are showing you now, and that we can deploy them using Docker. As for the hardware server, we will show you today how to deploy the hardware server after doing the build. Okay, so the deploy will be orchestrated by Docker for all those Docker packages, as the deploy for the hardware server is on the page that I've just shown you. So at this point, I would very swiftly pass the point to João again, so he can show you how to build and deploy the experiment.
Okay, I'm going to share my screen again.
I'm going to. Okay.
You can see my screen. Okay. Now, okay. So, no issues regarding the screen. Let me see. If okay. Let me see. Okay. Everyone has no issues. Okay. Thank you. So, for the build process, we need to have, as Rui said, we need to at the moment you will not be able to build the project locally, because we need to solve the dependencies that we need to add before so you can access publicly. Actually, it has our own we didn't finish it yet, so we are working on that, and later you can build it on your own system. But for the requisites that you need, you can check the README file. It has some explaining if you need to when we resolve this issue. But at the moment, so you can see what we are going to try, you need to have JDK 11 installed. You need to have Apache Maven installed also. You need to install also Apache Ant, because some parts of the process are built in with Ant package. And you need to have Docker also installed in your machine. So what we need to ensure in this way, we didn't change it yet, but if you want to build the WP training, we need to change the build pendulum properties that we talked before. We need to change it so that the process can check the new experiment here. What happens here is that this process, we have also other build properties. You can create your own, but it is advised for you to try at the moment with the one created, that we took the most essential parts of the properties. You can start with this. Later you can check your properties, because what happens in the build process is that we join this build property sample with the one the property file, in this case pendulum properties, so that we can generate the code. You can check it also later, but it's not really important. It has a lot of properties that you will not need for the moment. So just for you to understand how the process works. And what we are trying to do now to build this WP training, we have the command here to execute, and we need to change the experiment list so we can check the WP training experiment. As all other properties, the host name of the multicast is already defined. This one is all. We have all the components in Docker, so they recognize each other by the service name. They recognize. I can show you. We have the compose file that they recognize. They have the service Docker service name Elab multicast. So we set in the pendulum properties Elab multicast. If this could be a server name, as we said before, and now we have to set all the properties that we need. It is all defined, the lab ID and the ports that are going to be used. It is important to check these ones are the ports that the multicast controller opens. The 25,001 is the port that that RecWeb tries to connect via JMX. And the other port, the 9001, is the port that the multicast controller is available. So as these components are all together, we do not have to worry about network issues, but it's important to know that this exists. So now we are going to build the project. We have to be careful because of this property, build environment, as we showed in the slides. We need to change it to pendulum because the file is called build pendulum properties. So we need to change the environment to it behaves as the environment after the underscore environment, so that you can understand underscore environment. If you pass production in this property, it will go get this properties file. And now we need the build pendulum property, so we are going to send the environment as build pendulum. Now we're going to run this. Wait, Okay, so I'm not in the right place. Okay. You must be in the parent, in the base. You need to be in this directory. Not there. It guides the Maven guides by this POM XML. So you need to be where this POM is, the main POM, and now we are going to build it. This process will take a little, but now it is running the end tasks to compile the experiments and the multicast servers. So this now is going to take a while, and after this, it's going to build the Docker images. So now I don't know if Rui wants to take a little. This take about 5 minutes to compile everything. So Rui, I don't know if you want to say anything else.
Just to sum up and summarize it, all this process, as you may have noticed, we have prepared it as simply as possible, that it can become more accessible as possible for everyone. But since there's a lot of classes, Java classes, and a lot of things happening in the background.
Wait, sorry.
Sorry,
Okay.
you stopped recording?
Sorry.
Okay.
Sharing again.
So since there's a lot of variables and a lot of stuff that's going on in the background, today we tried to cover everything so that you can get a very good general overview. But you don't need to know all of this in order to set up the pendulum. Okay. So we wanted to give you the lay of the land, so to speak, and so that you can have a good idea of where you can go with this, of how far you can reach with this, and how much you can explore with this system. Okay. You don't have to know all of these things. If you want to create a new pendulum, you just have to follow these steps that João Cortes is pretty much just showing now. And we try to make it as simple as possible. Also, if you're going to start, if you want to do this process, if you want to create your own pendulum, and if you want to create it by yourself using the GitHub platform, I advise you to contact us, and we'll get you started also on the process. Besides sharing the instructions that we've shown you today with everybody, we'll evidently share it. But if you want to get started with it, just contact us. We will try to guide you through starting process so that you can learn how to get into it. I will stress, however, that the connection between the connections between servers, where the hardware server, or in this case the Raspberry Pi, that you have in your own facilities, in your own infrastructure, and the multicast that is probably going to be served by another infrastructure, another server, whether it's ours in Lisbon or Technicus in Lisbon, or another one created by another partner. The accesses between these two, the network access between these two infrastructures, will have to be as much as possible managed by you, by your personnel, because you're the only ones who know what firewalls you have in place, what system you have in place for a given server, what network, what kind of network is functioning at your institution, etc., etc. So that will be a lot on your side. But if you need help getting started, just talk to us. We'll get you started. We can provide some support on that, and we don't want you to feel abandoned or anything like that. Okay. So just feel free to contact us. Okay. And having said that, I can also.
It's going. It's almost finished. It's now building the Docker images.
I'm also sharing in the chat.
Okay.
Nope, not that. Having said that, I'm sharing in the chat room our dedicated email address for receiving and answering the requests. Here we go. Oops, sorry, I made a mistake.
At the moment, I think we already have the packages. It created the WP, as you can see in this Java. It already created the WP training hardware server. If we added a WP training 2, and if it existed, it will be created another zip file with the package. Okay, it finished. So now, as you can see, this take a lot, maybe some sort of 5 minutes, but at the end, we'll see that it created the Docker images that we are going to use. In this case, we are not using today we are not using the Docker images, but Friday we will show you the Docker images. Now we are only going to set up the WP training in the server, in the EST server. So now, just for you to see that it created the Docker images needed for all the components, the multicast, rec web, rec client, and also these page images that are not going, that serve as base to these images. So now we already have a dist Java. We already have this zip file. If we check what is inside this, it has the components that we'll need, the jar files that were compiled, that are needed for us to run the WP training, and the shell scripts that are needed for it to run the driver. So we are now going to copy these files to our server. I'm doing the terminal, but you can also use other applications to do this. I'm going to put in the TMP directory. Okay, and now we are going to the server. All you need to do now, I'm going just to check. Wait, a lot of processes. Okay, no, okay, wasn't this server. I'm mixing stuff. Okay, so I need to copy this to the Raspberry Pi.
Again, I take the opportunity to remind you that these instructions are on the web page already furnished, already shared in the wiki. Okay.
And maybe is better to clarify that this LABP is
alias. Yes.
No, it's an alias, but it relies on a Raspberry that is being used for example. Okay, in the future,
Yes.
This will be the Raspberry that hosts the pendulum.
Yeah.
It will help if you comment what you are doing.
Okay. So now I'm going to copy this to the Raspberry Pi server. So now, okay, I'm going to copy this to the Raspberry Pi server. at the EST servers. In this case, in the EST. Okay. I'm getting nervous. Okay.
Don't be. You're doing fine.
Okay. So now we have this WPA user that has the other experiment. We are going to switch to that user. And now on this directory, we'll create a new directory on the site. Okay. Maybe do a rec deployment. JDK 11 or WP training. I don't think this is going to work because of the property set, but I will fix it. And now I'm going to unpack that zip file that we transferred here. I'm going to unpack here. Okay, so okay. I'm doing this. Okay, and now we have this. Normally, we need to run this start the experiment, the start WP training. It will be named after the experiment name, and now we need to. These are the properties that are getting set to run the process. It's a Java process, as you can see. And it's ready to run. You only need to be sure that it has execute permissions, and then do a startup of this process. Maybe on the first time it is not going to run. I need to check if the serial ports are configured correctly, and maybe I need to send the other Java application that is running. Need to stop it. So. Okay, I'm going to stop the application, the Valparaiso hardware server that is running here. So I can run this other one. It can allocate the serial port correctly, but we will try. We'll try to run if we will see if we have any issues. Okay, so now we have another thing. Okay, maybe this. Okay. Maybe the template isn't getting all the information that we needed. Okay. Okay, we need to check this later. But
just run the one that you already had there. Sorry.
Yes. I can go with the other one that we already have. Probably I can check it later. The differences and fix the template.
There's probably a couple of differences still between the template. We're gonna fix that.
Yes.
The problem is about the GDK. Okay.
GDK. Okay.
Yeah.
Okay.
But we can see later.
Yes, I can see that later. Okay. So, what we need to have in consideration is this property files, as Rui said. We need to check in this server we have a different port. We have a different port set for the serial serial port. So we need to be careful with this. We need to check what the serial port is opened. We have a lot of them, and what we are using now is the TT TTI M0. We are using this. This was the port that was configured for the pendulum to start. We need to have caution that if we want to run with another user, in this case we are using user WPA. We have to be careful with the group. We have to add it to dial out, because as you can see, it is the group. If we not set it, we will not have permissions to run to connect to the serial port. This is one of the cautions that we need to ensure. So if we run this is one of the files. Another file that we need to configure if needed, but normally it comes configured, is the Corba location. It's one of the locations that it is configured when we build the project, and we pass that properties in the build pendulum properties. So we have this connection that is the connection to the multicast controller. As you can see, it's the 9001 port. So it's the only, we have to be careful with this. And now, what happens when we start this script? You will try to connect to the serial port. You're saying that is removing the lock, but now it's trying to connect to the serial port. And if we access to our, it was offline, but now when we check it again, it updates automatically, but I'm going to refresh the page. Okay, so now the state is okay. And if we run if you connect to the client, you can see that now it will be running. Okay. So now the client is running, and we can access it. If this hardware server was unavailable, we couldn't go further. This section would send us a timeout error message after a while. So now we are connecting to that hardware server. That is how the building process runs. I'm sorry for not being able to WP training to work, but maybe at Thursday we could make that run.
Probably have to change a few things also on there. Let me take the
yes.
perhaps the screen. I don't know if no, I probably have a few questions. Sorry. Okay, can you see me? Okay, and I'm going to share my my screen again. So evidently, you can use this. You can use this dedicated email list to pose questions for us. Okay. Again, we tried to give you an overall view of how the system can work. For next Thursday, and I will focus on that. The idea is how to deploy the remaining pieces of the network. So, namely, how we can deploy, if we need to, a multicast controller and a client, so that if you want to test this locally, you can deploy all these pieces in your own server, and you can test them, and you can build your own system, and you can study it further. For now, what I would say is that we're going to correct and still improve and maybe tune up the script for creating a new pendulum experiment with the inputs that you want. And that will be the basis of working to create new pendulums into the network. Okay. Then if you want to go further, next Thursday, we can approach how we can set up and deploy these things. And also the idea is that, and I outline it here in bold, is that we have a bit of a discussion on the debug and how the setup. So continuing on this session that João Cortes has now shown you, how can we make it more robust, and what do you need to know to get started, and to, if it's not working, how we can debug it, how we can fix it, how you can start to resolve these problems. So the idea is to next Thursday to pick this up a little bit more, and to continue it and clean it out, and see if you have any questions also, and also provide a little bit of these tune-ups that you can have to try and understand how you can prepare your systems to accommodate the pendulum. Okay. I've also seen that there were a few questions around, so I'm going to answer perhaps a few of them, if that's okay at this point. Okay, so we had the question of whether you can use Windows to access these systems. Yes, you can. Okay, so the idea is that you access the Raspberry Pi usually, which is a Linux system. You can do it using a Linux emulator on Windows. Then Carlos also suggested that we could have a list of variables that you should look at when you're doing these processes. I wanted to put that out to Thursday, where we have this kind of a debug mode or debug session, where we're going to look at the main requirements of what you need to have every one of these pieces working on the Raspberry Pi and on the multicast controller. What are the network requirements? What you need to be on the lookout for with this basic setup. Okay, setting up a pendulum. Okay, we're not going to go any further than that. Then you can study it on your own if you want to. But we're going to take a closer look at how you can set up a pendulum, and go into the debug mode. If you're getting problems, how you can resolve them. What is the usual practice? Things that João Cortes was actually mentioning now, that like what users and the user privileges that you have. So you should be aware of that. So we're going to try and summarize that next Thursday. Okay. So that everything is a little bit more cleaner for you, and simpler also, so that you can do that. Also, we had a question on when we go into the experiment here. If I exit, oh dear, sorry, it's kind of crashing. Okay, I can come back to this one maybe. But the question is, why is there a checkbox on login? Okay, here we go. Why is there a checkbox on login? This was posed by Junio. So when I'm performing the login, I have a question here about whether this is a public or shared. Let me see. I want to make it show in English. But this is basically a question whether the computer is shared or public. This basically enables a couple of options having to do with shared privileges, but this is mostly for teachers who have super user privileges and authentication methods. So we're not going to be using this one a lot unless you're required to have an authentication system integrated with the existing system. So that's basically it. And then finally, also someone was asking, when will this new version be available for all the pendulums? We had the option of having both of these options coexisting at the same time. So we're going to look into that. We're going to try and put out a time frame for this. But as you have seen during today's presentation, there's still some fine tuning that we need to do on a few things, namely the script and a few more options that we'd like to do with the build properties, like João Cortes was saying. We wanted to simplify that a little bit more. But we expect in the next couple of weeks to have a deadline for this, or to have a timeline for this for you. We also didn't spend much attention to that at this point, because we wanted to have things kind of laid out as you have seen today in the presentation, so that you could already see this working and already have a feeling for how it's going to be assembled. So as soon as we have some more information on that, we'll be sharing with you. But in the next couple of weeks, there should be news for sure. Okay. All right. So if there are no more questions for now, I would propose that in a general manner we'd meet again on Thursday, and we'd continue from there on. I'm also posting, by the way, I've already shared the presentation of today on the shared Google folder for the project. I will be posting the link, the direct link for that presentation here in the chat in a few moments, and you can already visit and navigate through the presentation, through this presentation. I remind you that all the links in the presentation are active, so you can just link that and follow those through, so you can have a better feel for what we've been talking about. And if you can look at it in the next couple of days, we'll talk again on Thursday and continue this work. All right. That's
okay. Thank you, Rui. I think we appreciate quite a lot this presentation with some glitches, but anyhow, I think people now can at least reflect on what is being done, and on Thursday we will come back to the more demanding part, that is the deploying of the servers. Okay, thank you very much, and we stop recording now. Okay. Before we leave, I just copy the chat so we can select some of the comments for later, and to be like facilitate the minutes. Okay.
all right.
June, you asked another question about the time frame. I don't know if you.
We are live, because I need a couple of minutes to copy these.
Okay.
I didn't see the question. Sorry.
Do you have a time frame for allowing access to GitHub?
Yeah, like I said, that's a little bit dependent on the fine tuning that we like to do now. Still, so this is fairly recent integration of GitHub and the migration to GitHub. So we need to still do a bit of fine tuning and fix some glitches that you still saw today. But in the next couple of weeks, we're going to have a time frame for you to base your decision making also. Okay.
Rui, just one thing.
Yeah.
It's possible to give access only for read in.
Yeah. Right now.
This period, it's in that period of time. But we need that you give to us a list of GitHub users for we can add at users that are allowed to access to the code. Correct?
Yes. Thank you, Pedro. Like I said, so just send us the users that you'd like to have access to the repository as of now, and we'll give you read access to the repository from this moment on. Okay. And then we'll prepare a wider time frame for everything else.
Okay. So see you guys, and have a nice evening.
Okay.
Okay.
I will be sharing. I was going to share the link.
Okay. You
I'm
can
just
share,
going to
but
share the link for the presentation, for today's presentation. I can send this via email too if everybody wants.
I think it's better, and we need to copy as well the links and send by email, because probably there are people that didn't come or forgot to copy it from the chat. That's why I'm saving the chat.
Okay, I'll send an email with the presentation,
Okay.
presentation sharing, and then we'll continue on Thursday.
Okay.
Okay.
So bye guys.
Okay.
Bye.
Thanks a lot, everyone. Bye bye.
Bye.
Sorry about the short set.